Okay, welcome to the next section. This we will now create the firmware for the D1 Mini using ESP Home. Right, this is a rough sequence of what I'll get into. Okay, so as I've shown in previous section, these are the two boards that are part of the project, two of the nodes. One is the DS18B20 Dallas temperature sensor on top of a D1 Mini, and then the other one is an OLED display, a shield on top of a D1 Mini. Okay, in the previous section I gave you a rundown of ESP Home and how it works. You can use the wizard to create templates or a configuration YAML file. Okay, so in this project the main component is the DS18B20. So what you need to do in the YAML file now is create entries. So at the top of the file you'll have the name of the project, the platform, and as well as the board that you're using. And then you will need to add these files. So you need to tell it which pin the Dallas 1 wire is connected to. So that's your data pin, the DQ pin. And then what you need to do is also tell it now the name of the device. So you can have many, under the sensor field you can have a number of devices. Alright, I'll get into the address soon. The other part of the ESP component is the Mqtt component. I'll get more into Mqtt when I get into the Raspberry Pi and how we create the Mqtt service inside the Docker. But the main thing that you need to know for the Mqtt Broker that's running on the Raspberry Pi is its IP address and obviously the username and password. There are other settings, but these are the three main settings. Alright, this is I use Visual Studio Code, but you could use any editor to edit this YAML file. So as one of the uploads I'll provide you with this file, but you can see what I mentioned before. This is the name of the project. This is the platform, the D1 Mini, and then you give your Wi-Fi credentials. And there's another thing where you can say if it doesn't pick up the Wi-Fi for 60 seconds it'll reboot. You can fix IP, which is what I do. It creates an easier situation where you know where all your devices sit. In the introduction and in the hardware setup I explained that in your router you need to go and set the DHCP range as well as and then you can so you need to plan a little bit ahead and say, okay, this is what's on my existing network, and then create a free zone and put all your devices in that area and sort of keep track of them, especially as you have more and more devices. You don't want to have an IP clash. Then as I showed in the previous section, this is the command that you will use, or that you can use. The name of the YAML file is sensor DS18B20, and so you would compile, you can upload it and run. I will show a video of what it looks like when you upload. Alright, here is what I mentioned. I'm going to show you a video of exactly what the whole process of compiling and uploading and everything is. This is Visual Studio Code. You can see here, here is the project on the left hand side here. You can see there. Then this is the YAML file here on this side. So there's exactly what I showed you in the slides. Logger, Mqtt, the Dallas, and everything. Okay. So what you would then do is go to the command line. You would type ESP Home sensor us18b20.yaml, and then you would write compile, and you would see it would now go through the code and build it. I did build it before, but this is an example now. So if you now went and said clean, this is where the clean command comes in. That basically now deletes the build, and if I then ran the build again, compile again, you'll see now it goes and fetches all the stuff new, freshly again. Gets the latest stuff. You'll see it shows in yellow stuff that's already installed. There it compiles all the code again, creating these are object files. You can see it gets put into this directory here. Creates the firmware elf file, shows you how much space is used, and right, so that's the compiling. Okay, so the next thing you'd want to do now is connect your device, plug it into the USB port. It will then appear as a COM port, depending on your computer or your laptop. In my case, it's COM17. So what you would do then, you would then run upload, and you'll see it now. Because I've done this before, it knows that I'll show you how the over-the-air works. And then this says your COM17. So all you do is you type 1. You'll see there it goes, and you can see it now. It's uploading the code. You'll see on the device as well, the little blue LED will flicker while it's doing this. So pretty amazing that uploaded in a few seconds. Alright, if I now go to the terminal emulator, I can go to a new connection, COM17. If you press the reset button on the D1 Mini, you'll see there now it's actually rebooting, going through the whole sequence as I showed in the video. You can see it found the sensor over here, and what it's doing here is every 10 seconds now it's sending a reading. You'll see every 10 seconds it'll send another reading, and this gets sent via MQTT now to your broker, and then in the next sections I'll show the setup of the Raspberry. You'll see that's the web browser now. So you see it shows here DS Sensor 1, and this is being served up by a web browser. Pretty amazing. You'll see it's actually even showing real-time the log information. Okay, what I wanted to show you now is as you saw before in the terminal emulator, the device is running. If you now went and you made some changes, you could then go and do an upload again. In this case, it will know that it was flashed once before. So you'll see here it sits here, it says over the air and the IP address. So if I enter 2 now, it will effectively upload via Wi-Fi. And if I go now to the terminal emulator, you'll see now how the device is actually rebooting. That it's rebooting now after being updated via Wi-Fi. So that's pretty amazing stuff. You could actually have a number of these devices, each on its own IP address, and the upload command will know from the YAML file what IP address it sits on. It'll find that device and it'll upgrade the flash over the air. This is some of the details in the file. So this is once again the same basic info in the header. These are the Wi-Fi details. Then further down now you have the option of enabling a web server, which will allow you to once this device is on your network, it's nice to be able to go into the web server and have a look at what the latest readings are and whatever the latest values are. This is the Mqtt Broker. Once again, in my case, this is an address of my Raspberry Pi, username, password, and the same. You can actually have it that if it can't reach the Mqtt broker, it will reboot the device. So this just makes your devices a bit more robust in the real world. This is just over the air enabled. And then this is once again which pin. In our case, the DQ pin is on D2 of the D1 Mini. So most of the pins of the D1 Mini are numbered D0, 1, 2, 3, 4, 5. And then this is the update interval, every 10 seconds. I normally do this in the beginning, and then you would want in the real scenario maybe only 60 seconds an update once a minute or once every 5 minutes. It'll determine how much readings you will have in your database as well as in your graph, which we'll get to in the next sections when we set up the Raspberry Pi. So one of the important things with the DS18B20 is each one of them has this unique address. So every single one of these has a unique address. So what you need to do is determine this address from the logs and then put it in here, because if you don't do that, then it will not, this device will not be kind of registered, or the sensor. So if you have a look, this is what the log file looks like. I will show you a video of real-time how this looks. But this is, I use TerraTerm, which is a terminal emulator, serial port emulator, and in my case it sits on COM17. So when you plug the device in, it appears as a COM port, and this, if you've enabled logging, then this is the kind of information that comes out. You can actually see here how it connected to the Wi-Fi access point. It even shows you SSID strength, the channel it's on, so it's pretty amazing. And then obviously you can see here it's connected to the MQTT, and then so it's, so I'll show you a video of how this actually looks in real. I think that's that for this section. The next section I'll show the OLED display.